Okay.
Juan, do you have anything to share today?
Um, I prefer to share it at the end. I will try to redone the process of the STM ID for porting the chips for different boards. So maybe someone find it useful because we are in the same problem.
Okay. Well, let me pull up. The only progress that I've made is well, I'm trying to get to GIST. Let me get to GIST real quick. Bear with me a second. Why is that coming up?
Oh no, this.
Yeah, I know, but it's not showing me my repositories. Oh yeah, there it is. And then share. So let me put this out on where's chat. So previously, I had, with Jeff's help and code, figured out those two settings to get full left and full right. I wanted to test this before I actually implemented it in my low-level sensor. Part of that was because I didn't know exactly how this map function was going to work if I sent it a value that was greater than one of those values. And sure enough, it tried to create a value that was greater than what I would have wanted it to send. So I just said, hey, if you try to send me a value that's outside of the range, clamp it to, full left or full right. So I got that code to a point where I was happy with the logic. And then I realized my microcontroller, which in this case is a teensy, is sort of buried inside of my control box, and I lost my ability to use platform IO in some software update. Platform IO stopped working, and so I fought with platform IO trying to get it to work, and I rebuilt another RPI and updated instructions on how to build an RPI using the Ubiquity robot image. And I know Jeff uses a full-fledged laptop, and you, Juan, are using this ST board. So I guess I'm the only one, maybe using.
No, I'm in the same page like you.
Are you? No. Okay.
Yes.
So anyway, I cleaned up these instructions a little bit, specifically around comment out the Ubiquity image before it starts up, and I added some information about how to make a backup image of the image once it's gotten to that point. And I started to add this instruction around updating platform IO and fighting with visual code, which really didn't get me anywhere. So what I ended up doing is moving over to Arduino has a command line interface. And so I think this is going to work in order to be able to remotely program a microcontroller that's connected to an RPi and doing it over the air. So I had success at getting this to compile. And all of this is, again, so that I can take this code and update my microcontroller that's connected to the RPi, because Platform IO has, I don't think it won't work with 1604. I can't get it to work with Kinetic and Ubuntu 1604 anymore, but Arduino CLI seems to. So that's where I'm at. I have to take one step forward and, well, 2 steps forward and 1 step back, and changing how to do remote programming over the air using this Arduino command line interface service.
Can you post a link to those extra documents you're showing?
Yes. So this would be, where's the share button? Dun, 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 dun.
The first one.
Thank you.
Which, don't you want the chat window instead of share? No, don't listen to me. You seem to know what you're doing.
Well, I've got to get the link so that I can put it in the chat window. That is the Arduino CLI. Yep. And then so that's what's going on in my world, is having to fix programming the microcontroller over the air.
I'm not doing anything.
Okay, Juan, over to you.
Well, I will try to do it, but wait a second. This will be messy, but I will try to share. Okay. I was having the last weeks I were working in 2 problems. One that I didn't exactly solve it, and other that I think that I come out with a solution. One of the problems was that as I run one of the simulators, my robot will get launched to the to the sky. And with one of the things that I have to do is to change the position of the original robot when we launch the Airbus and the gazebo. So I was working in that now. That's why I get this this window, but I didn't finish it because I think that I'm getting some kind of error in the problem. The other thing was that I was in one of the projects that I'm working, that is the same robot that I'm working in the simulation, is that the original robot, the middleware, is in with a board that is called STM32 Discovery Board, F4 Discovery Board. And we are not being able to get it in Argentina. So I have to migrate the project from that board, that is the STM32 F4 Discovery, to another board. And it's not so easy to migrate the projects in the STM32 platform, because you have to I didn't know how to do it. I asked Chef for help, and while we were working, I realized that there are two to work with that. One is let me show you. It's one is the STM 32 Cube IDE, and the other one is the STM 32 Cube MX. That is a different app. So here, when you launch the STM, you can migrate the processor. Start my project from MCU. Start my project from STM board, or start my project from an example. I will try to do it.
Remind me to come back to this point when you get done here talking.
Yes. Well, this is the way that the STM32 shows you your project. It's very different from the Arduino IDE, and it's shocking because you see the chip and you see the ports, and you got to solve this. And when you are very comfortable with the Arduino IDE, this is very difficult. But you got to go to here, I think, where it says the pinout, and then you have to go to the list pinout compatible MCUs, and then you will get this. That is a window showing you the compatibility between the different STM32 MCUs. The ones that are here in blue are fully compatible, like here it says, and the other ones are you have to change some pins. As a matter of fact, I'm in the yellow part of this chart. So now I'm working in changing the pins. I think that I have finished that process, but I wasn't able to flash it again to the board and test it. But this is where am I? But I wanted to show it because it wasn't easy for me, and due to the chip shortage, I think that this will be a common situation for everyone, because you have to work with what would you find, not what would you want. So that's okay. So there you find, you check the board and put OK import, and if you are lucky to be in the blue zone, you will go forward, but this is not my case. So that's what I wanted to share. Yes, Chef.
Why are you in the yellow area?
Because I have problems with some pins that need to be relocated, but I think that I have another problem that I'm not sure with one of the clocks, but I'm not sure. I have to work it more. It's something that I got it in the air.
Okay, what I would do, if you go back to that first page that said create a new project, and you had 3 options there.
I think I'm not sure how to go back, but I will try it. Ooh. No, this is not.
Maybe you just close it and start it again and say create new
Yes.
project.
Yes.
As many updates as that just loaded, it could be that it's been looking at the wrong part this whole time. It could be that whatever you clicked on just magically loaded in some stuff to fix some of the problems.
Yes.
Okay, now at this point, you've got 3 buttons there. One says create a project from an MCU, or start a project from an eval board, or start a project from an example. What I would do, I would click on that first button that says create from an MCU, and put in the MCU number that's on the discovery board, and build the project to the point where it shows you the pins and everything, and then save that project. So you've got a new project on that chip, and then go back and do the same process and pick the chip that you've got now and build that. And when you're done, you'll have 2 projects that will do nothing, but they should compile, and it should show you the pins. And at that point, then you can switch back and forth between those 2 to see what's different between the 2. And I think once you get to that point, the only difference you're going to find is it says, oh, this chip has 512K of memory, and this one has 1 megabyte of memory. I think is the only difference you're going to see, because from what I know, the pin out and the peripheral should be identical between those 2 chips that you have, or the chip you have and the chip that you want to match that up to. And
you know that something that I don't know, that I found out that one of the different is this one that is called package. I'm not sure what's the difference between, because if you think that they should be the same chip, they want this shouldn't have so much difference in the package issue. But between the 2 boards, I have a difference there.
Well, do you know your part number, Juan? Can you put your part number?
Yes.
Yeah, just select it by part number. Don't worry about all that stuff on the left. Just go down to the bottom. There says part number. So go down to where it says STM32F407, and then one of them is a one of them is a G and one of them is an E. I think is the difference between the 2. No, yeah, keep going down. You got to get the 400s, not the zeros.
But now I'm. Oh, yes. This one.
So don't click on the board. if you want to verify that's what you have, now go back and tell it. So up the top there, just back up where it said, and you don't want a 401, you want a 407. Yeah, right. Commercial part number. Just start typing again. Put in your STM 32 407. Yeah, F407. 407. And it's showing you board. So see at the very top, it says board selector. You don't want board selector. See, clear at the top, there's a tab. Clear at the top on the left. In blue at the top there. Go straight up, right. Up one more.
Yes.
Okay, now type 07 there, right where you at. Okay, now
Yes.
there's your choices. So you could have got it from that pull down, but you got a VE and a VG. That's the two that you're talking about.
Yes.
So the VG is on the discovery board, but don't click on that link. So you just click that processor. So here, let me move my pictures out of the way so I can see what's going on.
I think that is the one that is BET. The one that I got with the star.
The one you have now is VE, but the one below it that says VG is the one you're comparing it to. That's what the original project was on. So I'm saying create a project with one chip and then create a project with the other chip. And once you get up to the point, it says, okay, we've got something that's ready to compile. You can now compare those two projects back and forth. So at this point, if you just want to pick one or the other of those chips, just click on that, see what happens from here. And it could be that it's going to force you to pick. Well, over to the right, it just simply says it says the package happens to be a 100-pin package, and I'm going to assume that's true. The other stuff you're looking at, I think out in the yellow area, those all said 144-pin package, which is probably not what you had in the first place. So I might have been picking the wrong one. So at this point, there is a chip, a 407, that's ready to go. And probably, if you would say, it's been so long since I run this, somewhere you can click something that says compile code. So just up at the top, either under file or under, it says generate code right there at the top. It says generate code. Right there.
Where?
Upper right-hand corner, there's a tab that says generate code.
But sorry. Yes, here.
If you click on that, it'll say, what do you want to call it or something.
Yes.
That says project. You have to give it a name. So call it test or give it like VE or whatever
Test.
VE. There you go. Location, you might have to give it somewhere to put it, but the point is, at this point, it will generate a short little piece of C code that says this is based on whatever the blank chip is you just loaded in, and then once it's saved, you can go back and do the same process with the VG chip. And I think at that point, once you do that, you're going to get two projects that look identical, except one place it's going to say the processor number is, it's going to list one, and somewhere else it'll say that processor has 512K of memory and then it has 1 megabyte of memory. I think is the only difference you're going to see between these. And that right there will tell you when you go to your project you're working on now, which was created with the discovery board, it's going to have all that extra stuff for the board in there, which you don't really care about. So back to where we started, there were three options. You could either create it from a chip, create it from one of their eval boards, which just simply loaded a lot of extra information that you don't need, or it said from an example. And I don't know what their examples were, but that's the difference of those three buttons at the very start, where you very first started out. So you're saying you're down in the yellow area there. I don't know how you got into that or what it was talking about. But it looked like none of those chips matched what you had because they all said 144 pin chips. And I believe this one is a 100 pin chip.
Yes, yes. But the main issue was that I didn't find my board. You have two ways to find out the board. One way is through the name, the other way is through your configuration or the specifications of your board. So you have to go clicking. That was why I was asking which was the difference between the packages. Because I found out that I was able to go there because I selected chip and the other things, but then I got stuck about the package issue and I didn't know how to continue. And I was expecting to find out someone to ask. But first, I wanted to compile the code and upload it to the board and find out what was happening in the debugger of the board.
But my point is, you don't have to know what the board is. You don't care. You just want to say, here's the process that I'm using. Because when you select a board, it's just taking all the extra stuff that somebody's defined. If you select a discovery board, it says, oh, you got this fancy audio chip on the board, and you've got 4 push buttons on the board, and you've got 6 LEDs, and it's got a bunch of other stuff. You don't have any of that stuff anyway, and you don't care. You just want to say, here's the processor, and you load the code in, and everybody should be happy. You don't have to specify your actual board anywhere, because that just adds extra stuff that you don't want anyway. So that's why that's why they give you the 3 options right up front. You can just say, I just want to pick a chip and write code for it. Or if I happen to have an eval board, you can specify that, and that preloads it loads in a bunch of stuff that you don't want, that just confuses the issue. And then the examples, I don't know, as I said, I don't know what's in the examples.
Yes, the thing that maybe I'm not understanding is how, because all the projects, when you run it in the STM IDE, begin with the pins not open. So you have to some way tell the IDE that some pins got to get open.
Well, you've got the .ino file that's in your existing project that you started with. That should be valid for that. That's what defines the pins right there. So one option would be to load up the discovery project that you started with, and then there may be somewhere there it says change processor type or whatever. And if you just change the name of the processor from a VG to a VE, that may solve all your problems and you'll be ready to go. Because it's already defined all of the pins, and the pins should be identical between the 2 chips. So I think that should work. I haven't actually tried that, but the problem is you're gonna have all that extra stuff in the way for the discovery board because it was built on a board as opposed to just the processor. So it may complain about things. I don't know what's gonna happen there.
Let me try it because maybe it was.
Well, wouldn't the process be the same for the discovery board? He just needs to find the exact part number for the discovery board.
But the problem is the discovery, they're trying to help you out by adding lots of extra crap that you don't want is what the problem is. If you say start with a board, it loads all kinds of extra stuff in there and predefines all the pins on the board, which you don't want anyway. When I say predefines, it says like say pin number 3 goes to the fancy audio processor chip, which you don't have. If you watch people's videos on YouTube, they will say, okay, we've got a discovery board. So we'll say, build a project on the discovery board. And it brings up that picture he had with all the pins. And it says these pins go to LEDs and push buttons and fancy audio chips. And they say, okay, so the first thing we'll do, we'll click the button that says clear all that crap out. So they started with a board, but then they click the button that erases all that. And then they just start from scratch anyway. So is this the...
No.
I would say at this point, load up your the discovery board project that you know,
Yes, I would
like right from the repository. Load that up and let's look at that.
Ah, bueno, gracias. Was it that? You see, you can work with, no, continue.
That is telling you that you switch software. It says, do you want to pull in the data from the cube software into the CubeMX software? And it probably usually says if you do that, you can't go back. That's what they usually tell you.
Yes.
Okay, so at the top there, it says the processor type is 407 VG. And this probably, yeah, if you look at those pins, yeah, they are labeled, you know, servo 1 through servo whatever. So this probably is, you know, these pins were defined for whatever your project is. Now, the problem is, since it says the processor type is a 407 VGT as opposed to VET, somehow you have to change that. So I don't know if you can say, let's see, project manager. Click on project manager, right? Yeah, right there. What does that show you? And you might be able right there just to change that to a VE as opposed to a VG.
No, it doesn't let me. No.
Okay. So let's see, project. We're on project. So firmware project. So one option you could have, you know, you just went through and created something based on the VE chip. So you've got a project on that.
Well,
you can
the one that here you go to the list of pinout compatible MCUs, and here was the
now these have the right package this time. So right there is a 207 VG and right above that is a VE. And it says that's fully compatible. So on
Those
on
are 207s or 20 somethings though.
Oh, that's right. So yeah,
no,
down,
F2.
There's a 407 second from the bottom.
about 2/3 of the way down is a 407 VET.
This one.
Yes. What now? What's it doing at the bottom? It says loading something. Maybe you just have to wait for that.
Yes.
My thought is if you click on that, it may say, "Oh, do you want to substitute that?" Or we'll see what it says here.
This was the process that I ran, but let's test it again.
There's a button there that says "OK import." I don't know what that's doing. It might be best to find a tutorial. Say go out on YouTube or go out on the SD Micro.
Yes, that's the there are not a lot of tutorials about this. I only found out two, but maybe it's my fault because I didn't search it right. But we are following the steps that I found out that we can follow. So now this will stop the MCU loads. It will paint the different rows if they are compatible or not compatible. You can select OK import, and you will change the project to the new chip. But
right there under comments on that line selected, it says full compatible.
Yes, it
So
changed.
I wouldn't think you have to change.
No. VET.
Yeah, VET. So
So you press You
Okay.
mark it like this.
Okay.
And now I think that you go here too.
And if you notice, see, all your pins are still labeled the way they were. If you look in the upper left-hand corner, it's got the new 407 VET chip. So
Yes, I
technically
think
this,
that now I got to generate the code.
see what it does.
Yes.
That thing you just typed in where it said folder location and you typed it in, that's probably not what, that's probably saying where is your software loaded, not where your project is loaded. So that might be a problem right there.
But I was typing here in the name of the project and it get.
I see what it's doing. Okay.
Okay. So I think that I'm done. Oh. Again, generate the code. When RTS is used, we strongly recommend to use HAL time-based source other than stick the.
I would say go ahead and say yes to that. That may be handy to know in the future, but I think it's, it's doing it the same way it was done on the discovery board, I think.
Okay.
It says it is loaded.
Yes, the code is successfully generated. Open the folder. And now I think that I have to open this with this one, with the STM IDE.
No, I would open it with STM32MX, CubeMX.
Okay, I can shut it down. It's not a problem.
I think you want to do everything under the MX, which is the newer software.
Okay, so I will have to go like this, shut this one, and this open.
Did that have something else open with that project you were just playing with? If so, you may have to.
No, I have to go. Wait a second.
What's that thing at the bottom? That you had two windows showing there. What's the one on the bottom? What is that?
This one? Oh, no.
See, you may want to close the one you had if it was open with the wrong software.
No, I close it. I have just. I will do it again.
Okay.
To be sure, but
maybe that was just showing directories is why I was confused. And this is the CubeMX software you started with, or that's what's there.
Oh, so here we got no window open, so we will regain the process. Okay. And we will open it from,
right there, it had several projects listed. You probably could have just clicked on that project that showed that.
On the left-hand side in the software, it was showing you recent projects. Not in your operating. There you go. Stop.
See,
there
right there. If you just click on that, I would think that would open it.
Fix it. I'm in current preemption priority system. Then
for the moment, I'd say Well, we can look at it if you want. I think it's going to tell you to change one number to another. And if not, it may be a big mass change we have to do here. If you just say no to see if we can get past this.
Okay.
So
I think that
see, once
in
you
the
get this
next
figured
group-
out, you could go back and do all these steps again and say, is this what we want? Once you figure out the steps through, then start from scratch again and go through and do this. But at
Yes.
this point, it opened that. If we say, how do we get back to, so right now, nothing seems to be complaining. That looks like the appropriate pins you're supposed to have. In the upper left-hand corner, it says 407 VET. So we've got the correct processor now. So somehow we can get back to the code, project manager, software.
That was why I was choosing the other IDE.
It could be that is what you have to do. I'm not sure. I think on mine here, I can just start mine up and see how I get to that point. Cube.
This is no, you know that something that I was able to do. I was able to go forward with this because I got, when I get this my new laptop, I put the dual boot and I run it from Windows. And from Windows, it was much easier to understand. So.
Across the top, you've got two rows of tabs. One says tools on it. What is if you click on tools, what is, oh, you were just there, weren't you?
Yes.
Generator. And let's see, what's the name of this program we're running now? It just says CubeMX, tools, MX. It doesn't specifically say it's the
I think that yes, here. No.
But I think at this point, you have created a project and you've renamed the processor. So I think you're ready to go if you can get it to compile.
Yes, I think that I got to run it from the, sorry, I will shut down this.
Okay.
And I will try to open it.
As you open this, see if it complains and says something about complains the difference between MX and IDE. Because at one point it said, oh, it'll say something about this is the old software. Do you want to convert it to the new software? So we'll see if this complains when this comes up. Now, I was thinking when they came out with one called CubeMX that it had the IoT editor built into it and it had the IDE stuff built into it. And maybe that, and if you are running on Linux, maybe it acts differently than the, because I was running mine on Windows. So maybe there is just something funny about that.
That's one of the things that I don't understand, but there are, oh.
And one of the problems you have, if you're trying to open the IoT file, that's just the pin file. That's one reason why you might have a problem here. Yeah, there it says IOC, I guess it's called, and that's just the pin file. So the project should have been. I can't think of the project's gonna be called. That where it says .ioc, is that a name you put on it, or is that, see up the top?
No. IOC is one of the extension of the STM32 IDE. I'm not sure what is the name, but it's the extension of the IDE.
And I think IoT is the file for your pins, which is why when you open that, it keeps showing you that pin file. But somewhere there's got to be an overall the actual project for this, which when you typed in a project name, that's what you should be looking for at this point. Does this have an open recent option?
No, let me try to find. Yeah, here.
Right, yeah, right there. What's that one?
This one is.
And let's see, import projects. You may have to do an import here because of the way, what's this called? Eclipse, the way Eclipse works. So you may have to say import and then it'll create this new project. So we'll see what it does here.
No, maybe.
Well, we can look at it this way. Whatever you did to start with the repository and open it and do stuff with it, we've essentially done the same thing. We've just changed the processor name in it. So whatever it took before to get up to the point where, what?
No.
No projects are found to import. Well, but the point is, we were able to change the processor name, and that was the whole thing. And I think just change the name will fix all the problems. You just have to figure out how to open it and get it to do something.
Yes. And
so even though it's trying to take you down the line of all these pins have to be changed, I don't think you have to change anything. If we just change the processor name like you did, I think everybody will be happy. You just simply have half as much memory now as what the other processor had. And I have no idea how much memory they were using, so it could be you'll run into a problem. There's not enough memory on this processor, but we'll see.
We will see. So I will try it again and receive a video when you upload it, because surely I will miss something.
And the fact that, again, it's saying that the .ioc file is not supported, I think it's trying to open the .ioc as a project, and that's not what you want. So somehow you have to find, but on the left there, it's, on the left where it says firmware that's highlighted, drag, open that box, hit the little.
I will try to do open like this.
So on the left there, where the little box that says firmware is highlighted, and then the little box. Oh yeah, pull it down. What do we got in there? So there is.
No, but this is another project.
Hold on. I realize that, but under there, if you look under middleware drivers core, open core, I think is what you want. And then under source should be that's all your C code to make this thing run. Actually, there might be one of those is probably your actual C code to run it. But anyway, this shows us it opened this project, and that's what you're looking for. So now, when you first started out, say at the top there, it said, I don't see anything naming this, but as you went through the steps to open this, it said, what project do you want to open? Whatever the name for that project was, you want to find that as the new stuff.
Okay.
So don't try to open something called .ioc because that's not a project. That's just simply the pin file.
I will try to do this again from zero with the fresh repository clone and go forward from there, because
And when you do that, you create it up to the point you have, and then you say generate code. It's going to say, oh, you have to give it a project name. Now put a name there without any extensions or anything. Just call it test, or call it test 24, or call it Juan, whatever you want to call it. So it's something you specifically know what you just typed in, and then you can go look for that later. So after it generates the code, it'll say, okay, I created your project, and then it also tells you what directory it's going to put that in. So that will give you, on that page, it tells you where it should be located.
One thing that is that I'm not sure is that here, I will try to find out more about the difference between the MX IDE and the other IDE, because like this, we have created an MX project. You can see it here, the original. So it's not the same that we were trying to achieve.
So this, okay, that's saying this directory is what you just created.
Yes.
Okay, and it could be the fact that, did you type in that .ioc as you're creating the name? Because it says test2 stm something something .ioc. Did you type?
No. That was when we generate the code, this file was generated.
So if you back up one directory level at the top there, it's got those 3 tabs across there. Yeah, click on that one. And does one of those options say open this?
With another application like this?
Yes. Yeah, just click on that. What's it say?
Oh. No.
And how do we know which project we have here? Firmware. On the, let's see, how can we find out? You got the 2 on the left where it says firmware and it says NOAA something. Pull down the one that says NOAA. Open that one.
Yes. No, but this one were the ones that I were.
Look right there. See that it's got your new processor name stuck in there. So this is what you want. This created this. So if you click on core right there.
No. I no.
No,
sorry.
this is what you want. Click on core and open that up.
Yes, but I built this last week.
Well,
this is not or last build one. This was the one that I built last week after you explained that I realized that I was making that error after you explained me. But I can do it.
What we just did here. Don't open the IOC. Open the one that says core. Pull the one down that says core.
Yes.
And look under source. Okay, system. So somewhere in here is the actual code. There's a main down there. So main. Anyway, the one you just created now, I thought you called it test2 something something something, and
yes.
What you just opened was called test2 something something something. So again, that's why I'm saying when you name it, make sure you know exactly what the project name is going to be, and the way you just opened that, where you went to that directory and it said, here's my NOAA, here's my one I just created, here's some other stuff, and you said open with IDE, and it did open. So that's the steps you want to do once you create that.
Yes, but I don't know why it's not opening.
I would say back out to the level we just had on the directory. So I don't know if you have to close this or whatever.
Yes, I have to close it, but I want to try something. Oh. Okay.
So yeah, go stop right there. Stop right there. What are these different projects across there? That test two something is the one that you created last week, or is that the one you just created now?
No. Let me see. The ones that we are seeing. No, nuevo. No. Otro.
So I think that one called test two. We could look at the timestamp on that directory, but yeah, because I don't think timestamp changes on directories. So if you look at the timestamp,
It's
so that was created at that time today. So I think that is the project you just created. And if you say open that with IDE, I think you're ready to go. And I think it should compile.
But I'm doing that, Chef, but it's not doing what we want to do. If you see, I will bet you see, and I select this, but you will see that it opened another. I don't know why we are not able to see the project.
I believe that's what you want right there. The only difference you're going to see is under processor name, and that it has changed the processor name. So this is the discovery project with a new processor put into it. So the names over here where it says NOAA, whatever that is, that simply came from the original project. So that name's not going to change. And if you pull that down and look at it, it's got the new processor number in there. So I think this is exactly what you want. You compile it, it should load onto your new board, and everybody should be happy, I think. Except you might have to fix those ones that said something about it didn't like priorities. You know, those things that popped, there's 2 or 3 things that popped up saying, oh, that's not quite right.
Let me try to do something. Because,
And a quick way to verify is start with your, you start with your project and change, put a comment in the code or something, and then go through this whole process and then open it up like this, and your comment should still be in the code at that point.
you know,
So I didn't see what you just opened there, but apparently it's not happy with it.
no, I opened the same one that we were opening, but it didn't give me. I didn't get nothing.
Well, do the exact steps again and see.
Okay, here is our project. I go to open with another application, and I put the STM32 either.
Okay.
I select it, but when it opens, there is nothing.
Well, I would say possibly you damaged that project somehow. If you go back out to the directory again and then go into that directory and see if something changed inside of there. I don't know how you know if it changed, but
it's the same. I will try to do it different now. I will go. One of the things that I'm not sure why is why I cannot select MX to open it. So the thing that I'm going to do is to open this like this STM.
So again, right there, it's got on the recently used projects. I would think you could select it there or look in. Yeah.
But
Again, it's trying to open your IOC file, which I don't think you want.
yes,
So it could be the MX is just the pin editor. I'm not sure anymore what the difference between these different things are. I know on the Windows one, I opened one program and now it's got the pin editor built into it. It's really hard to find, but that I just have one program. And when I type it in here, I don't seem to get.
here, load the project. But it's, well, let's go from here and see what's happening. No.
Okay, on mine, let's see, mine is simply called STM Cube IDE 1.2.0. Let me open that, verify that really works. So I maybe the MX is just simply the pin editor, so that, and if that's true, then at least on the Windows one, from inside of the normal IDE, if you can find the right button, you can say open the pin editor, and it probably starts that MX program.
Yes, I think that one of the things that I will try to do is to open this from Windows, because I'm thinking that one of the problems is with the how I'm managing this from the Linux. And the most of the documentation is in Windows.
Okay, so just as a point of reference, I just opened what I was running in Windows, and it does say Cube IDE. It does not say Cube MX. So I think Cube MX is just the pin editor, and at least in Windows, you can get directly to that from the normal IDE. So you don't have to run it as two separate pieces of software.
Yes, that's right. But the problem was that when, let me show you which was my problem. Wait a second. Okay. Okay. This is the original firmware for the board, for the discovery board. And I will try to replicate which was the problem that I was having, because when I was trying to migrate the project like this. To the workplace. Okay. It's thinking. Okay. One of the things that I was trying to, this is the original project. When I wanted to go to the pinout, but I don't know what is the problem. You will find out that I was trying to do this, and I don't know why. When I try to export it, you can see that here, down here, near to close, there is not the export.
Well, possibly that's because you can't do it from within the pin editor. You have to pull up the actual project, which is on the left there. So I would say close the pin editor, which, see, in this case, you are running the ID, and your pin editor, which is the cube MX, did come up inside of this
Yes.
thing. So if you
Yes.
close this window, it could be if you on the tab where it says firmware.ioc and close it there. Okay, now
Okay.
if you go up under includes course drivers, at the very top when it says firmware, if you just click on that, does it say anything, or does it just close that stuff? I was thinking maybe it's got something there.
No. Properties.
Yeah, project resources. If somewhere there it gives you if you search through this and find the software, the processor number, that's because that's what you have to change. Once you can find that.
The place that you can change this is here. The device configuration tool.
But
That
I thought we just tried that. That didn't work.
No, the problem is that I don't know why when you go to this, to the
Okay. And so this is what you just did, where you said click on compatible MCUs.
yes,
And
but it's not letting me change this.
Okay, compatible. Load MCUs. So when it gets all loaded, go scroll to the one that you want and click it and see if that then brings up the.
I have to go to the bathroom.
Okay. It occurred to me I can pause it, so I did that halfway through that. So right there where it says 407 VE, click on that. I'll go up right there. Click on that one. Then does it show up? No, it still doesn't show up down there.
No.
What if you double click on that? Does it do anything?
I'm doing that. No, nothing.
Notice on the left it says you're running low on memory. That popped up about halfway through that loading. I don't know if that
Yes.
is a problem, but so somewhere I thought you went through these steps and it actually worked. So I don't know what the difference was, but
Yes, but that's why I'm saying to you that I will try to use it to use the Windows version, because I'm pretty sure that maybe that got something to do with that.
okay.
But I will try. I will try. I'm not sure why it's different this with the other.
And just to sum up, it looks like all the steps we've gone through here actually fixed the problem. So if you can be able to pull up a brand new project and say, select compatible MCU and pick it and say update it. And then at that point, I think it should be ready to go. I don't think you should have to change any pins or anything else. I think it should compile and probably load right on your new board. Now, it's going to be up to you to figure out if pin number 3 goes to a servo or if pin number 3 goes to a push button or whatever is on your robot. But that's just a matter of when you wire it up, you physically have to plug into the right pin on the board. So I don't think you have to.
Yes, it will be test and error to find out my next step is to find out that the ROS system will boot up, will rise, and get some kind of information from the middleware, like a ROS topic or some kind of that, because that's where I want to, because to test this and find out where the pins are okay, I will need some kind of feedback from the ROS system to try to know if I'm getting information from the encoder or that kind of things.
How are you connected to your ROS system? Do you have a USB cable plugged in? Did they have it plugged into the discovery board, or how did they?
No, it goes through maybe I'm wrong, but it's the 14 or the 15 pin of the BlackBerry, of the from the past, from the Raspberry Pi.
Okay.
I can, if you wait a second, I will tell you. But
so I assume it's like a UART interface that they're running, and that avoids all it avoids all the USB mess that you would have to do otherwise.
Yes.
So yes, you just have to figure out on your new board which the UART pins are, and then hook it up to your Raspberry Pi. So yeah, that would be a very good thing to try right up front.
No. I don't know why it's saying running low on memory.
You probably have too many things running right now.
Yes.
But yes, if you can load this on Windows or on Linux, maybe run it on Windows and do the same steps and see if it looks like it doesn't.
I think that my next step is try to do that, because that will clear that it's not a software issue, that a difference between the versions in Linux and Windows. And maybe from that I can put a question in the forums, because I get to this way of solving this because I found out a post in the STM32 forums on how to migrate the projects, and they refer to the documentation, and this was the way that I needed to do it. But I don't know why I cannot open the project like I want in the.
Well, it opened several times, so it's something happened. After about the third time it did that. So possibly you create a new project from scratch, and you were doing a lot of extra clicking on stuff here that probably didn't help. So I would say create one from scratch and see if it works or not.
Okay.
And the other thing is I'd say do not run that Cube MX software directly. Just access that through the IDE. And to get to that, once the project is loaded, you go over to the left, and one of the things says firmware.iot. If you double click on that, it brings up the Cube MX inside of IDE. Now, I don't know if it matters. If it may be no different than running it externally, but that way there's less confusion, because you just start the one program and everything's accessed from the same spot. It could be it would complain if the IDE is open and the MX is open, and I'm not sure what's going on, but I would say if possible, don't run the Cube MX directly, and just always run the IDE, since that seems to be the way they want you to do it.
Okay, so the first thing that I will try to do when I boot that in Windows will be try to do that without rising the Cube MX.
Yes. In fact, I think on Windows you say open that project. The project right from the repository. Say open that, and then on that one to change it, you click on the, over on the left, it will say firmware.iot, double click on that, it'll open your MX, and then go through and do the steps of changing the compatible processor like we did. And then I don't know if you have to say save it or whatever, but then that your project should then be ready to go once you change that processor name. Then go ahead and try to, and at that, don't say, well, I guess you could say generate code, because it's smart enough to know if they wrote the code correctly. They got these little blocks that say don't overwrite your existing code. There's some echo that's really annoying.
Oh, no. I don't listen to the echo here, but it's the main problem is that it's not easy to handle this, the STM32 either, but I'm not sure if there is another way to solve this, at least in my case, for flashing and solving when you cannot find a board, because this is a common problem now.
Are you able to write code in the IDE and download it to your new board?
Yes.
You have a way to do that?
Yes, because I was able, this was a month ago when I was telling you that I was able to flash a blinking code to the board and be sure that the LED was blinking, but I didn't try to do that from Windows. I was able to do it from Linux. So maybe I have to go back to those steps to try to repeat those steps in Windows to be confident about what I'm doing flashing to the board.
Yeah, I think once you compile it in the IDE, it generates a hex file, and once you have that, whatever it takes to load that onto the board is probably what you need to do.
Okay. Chef, I will have to leave now. Thank you for your time. I hope that this will be useful for someone in the same problem with the boards.
Yeah, if people try using this board, that would be good to have this online. So if nothing else, to see how aggravating it is trying to get this stuff to work.
Yes. Well, thank you.
Okay. See you next
Bye.
time or whatever. Goodbye.